In this video, we're going to do a couple of extra examples looking at limits as x tends to infinity. So we call these limits at infinity. So the first one here, so we want the limit as x goes to infinity, and our function is 3x squared minus 2x plus 12 divided by 4x to the 7 over 2 minus root x plus 4. Okay, so if we try to think about what happens as we get a big number, as we plug in a big number, the top is going to go to infinity. The bottom is also going to go to infinity. Okay, so we don't know which one is going to win. So we're going to have to transform this a little bit. Okay, so what we're going to do is pull out the highest power of x, or actually, let me just erase that. So what I want to do is multiply the top and the bottom by the highest power of x on the denominator, which here is 7 over 2. Okay, so you could also divide each term by x over 7 over x to the power 7 over 2. Okay, now this is going to be the limit as x goes to infinity. So we're going to have to expand this, so to put it to each term. Okay, so that's going to be 3x squared, over x to the 7 over 2 minus 2x over x to the 7 over 2 plus 12 over x to the 7 over 2 divided by 4, because the x to the 7 over 2's are going to cancel. This one is root x is x to the 1/2. Okay, so now we're going to simplify. So each time I have x to some power divided by x to some other power, I can subtract the exponent. So I'm going to cancel as much as I can. So on the first one, I can take out x squared, cancel x squared. So that's x to the 4 over 2. So I'm going to be left with x to the 3 over 2 on the denominator. And the second one, I'm canceling an x. So that's going to be x to the 5 over 2. And then the 12 one stays. Okay, on the bottom we still have the 4. X to the 1/2 is going to cancel. And I'm going to get x to the 3. Because 7 over 2 minus 1 over 2 is 6 over 2, which is 3. Oops. And now the limit laws let me put the limits through. Okay, so this is like the limit as x goes to infinity of 3 over x to the 3 over 2 minus the limit as x goes to infinity 2 over x to the 5 over 2 plus the limit as x goes to infinity 12 over x to the 7 over 2 divided by the limit as x goes to infinity of 4 minus the limit x goes to infinity of 1 over x cubed plus the limit as x goes to infinity of 4 over x to the 7 over 2. Okay, and now we know these limits. Okay, so anything that's a constant divided by some power of x goes to 0 as x gets really big. So this is going to be 0 minus 0 plus 0 on the top. On the bottom, the limit of a constant is always just a constant. So that's going to be 4 minus 0 plus 0. So we get 0 over 4, which means that our limit approaches 0. Okay, so our limit here is going to 0. Okay, so now these next two use the exponential function 2 to the x plus 7. So it might be useful to know what the graph of 2 to the x looks like. Okay, so if I have my axes, okay, the graph of 2 to the x looks like this. Okay, so that might be useful because then we know the limit as x goes to infinity of 2 to the x. This approaches positive infinity. And the limit as x goes to negative infinity of 2 to the x is going to 0, right? Because as I get close, as the x values get really small, the y values are approaching 0. But as the x values get really big, the y values are growing without bound. So they're going to get really big as well. So as x goes to negative infinity, what is x plus 7 doing? Well, x is going to be a really, really big negative number, and I'm going to add 7 to it. That's not really doing anything. So I also have a really big negative number. Okay, so that means that 2 to that power is going to approach 2 to the negative infinity, which we just said is 0. Is approaching 0, I should say. Okay, so what that tells me is that the limit as x goes to negative infinity of 2 to the x plus 7 is equal to 0. Okay, so now we want to try this next one. So again, here x is going to infinity. So that means that x plus 7 is also going to infinity. So 2 to the x plus 7 is approaching whatever 2 to the infinity would approach, which is infinity. Okay, so this limit is not going to exist. The limit as we go to infinity of 2 to the x plus 7, so it doesn't exist, but it goes to positive infinity, so we're going to write positive infinity. Okay, so that's a DNE case, but we know that it's positive, big number. Okay, so let's try this one here. So we're going to use the same trick that we used in part A. Oh, I have 2 part C's here. Okay, part D. We're going to use the same trick we did in part A, where we're going to multiply by 1 over the highest power of x in the denominator. Okay, so that's going to give us the limit as x goes to negative infinity. The root of x squared plus 5 over x minus 1 over x divided by 3 minus 11 over x. Okay, now I know what this limit does. I know what this limit does. I know what this limit does. This is the only one I'm not sure of. So what I want to do is try and simplify this. So I want to bring the x inside of the square root. Okay, to do that, it needs to be in a square root as well. Okay, so what I'm going to use is the fact that x, we hope, is the square root of x squared. Okay, now we want to be careful here because we're approaching negative infinity. Okay, that means that this number is negative. I should have written that first. Okay, so this number is negative. Okay, since x is going to negative infinity, so it's going to be a negative number. Over here, the square root of x squared is a positive number. Okay, so it's not actually equal to x. So what we can do is put a negative out front. Okay, so the square root of x squared is going to give us the absolute value of x, but I want to actually get x back, so I need negative that. Okay, so now we can replace the x there. So this is the limit as x goes to negative infinity. It's going to be the square root of x squared plus 5 over negative the square root of x squared. Okay, so then we can put it in the same square root. I think I can fit it here. Okay, so it's going to be negative, and then the square root of x squared plus 5 over x squared. Okay, so now we can simplify inside of the square root. So it's going to be negative, so it's going to be x squared over x squared, so 1, plus 5 over x squared, minus 1 over x squared, all over 3 minus 11 over x. Okay, and now we can compute the limit. Okay, so like we did last time, I'm not going to write it out, but the limit can go inside of the square root. It can go to all the terms. Okay, so all the terms that are constant over x, okay, these terms all go to 0 when we take the limit. So what we're going to be left with is negative root of 1 plus 0 minus 0 over 3 minus 0. So we're going to get negative root 1 over 3 as our final answer. Okay, so the original limit, x goes to negative infinity, square root of x squared plus 5 minus 1 over 3x minus 11 is equal to negative 1/3. Okay, that's a tough one because you had to realize that since we're going to negative infinity, the x's we're working with are going to be negative. Okay, so that makes this rule here a little bit more complicated. So x is not actually equal to the square root of x squared. Okay, so that gives you absolute value of x. Okay, so because it's negative, we needed the negative out front. And that's why we have at the end a negative 1/3. So those are a few limits at infinity. So as x is approaching plus or minus infinity.